Swayam Prabha. Digital India. Educated India.
Dear students, hope you all are doing well. Welcome to another exciting session of the course Soft Tissue Characterization and Applications. So till the last class, we had been looking at the finite element modeling of soft tissues, and we were trying to learn all the techniques, how to reach to that point where we can study a basic geometry of a soft tissue or an organ and work around it when there is a single body versus when there is a multiple body. So specifically in the last class, what we have studied is how to have something which is known as contact pair between two meshes, right? Like what if there is a straight gap between two bodies, but we had specifically focused on two flat bodies. What if they're just touching each other? What if there is a slight gap? Then how do you make them interact, right? So that is what we studied, and in this class we are going to take it up from there and start with something where we have curved objects or curved systems, curved geometries. How do they interact? How do we apply the contact pairing to that? This will also provide as a refresher to what we did in last session, right? So let's get started. Okay, so we are back to the ANSYS window. So what we are going to do is kind of follow the same steps just as a refresher. I like doing that every time because this kind of gets you going and makes you remember all these steps which we left behind. So element type, add edit, solid 186. I'm just going to move through them very quickly, assuming that you all have already learned it and you are able to get pretty comfortable with ANSYS, right? Next is material models. Doesn't have to be now, but has to have like before the meshing is applied. So I'm going to have two different material properties, one with 1000.4 and the next one with maybe 500.3. So these are my two materials, but they will have to be applied to the mesh, and before that I need a geometry, right? So here what we are going to work on is not flat geometries, but we'll try to get something a little curved. So one of the things which we can work on is maybe a sphere. Let's do that. So we want to first of all create volumes, which is a sphere. We want to create a hollow sphere just depicting something which is very close to the human bladder, for example. So we're going to simulate a human bladder and a human rectum in a very simplified manner and try to look at the connections between them. So that's what our focus would be, right? So let's make a hollow sphere which is indicative of the bladder. So it has to start from x and y 0 0, right? And could have a outside radius and an inside radius, right? So these are the two radii. So I'm going to put the inside radius as number 1 and maybe the outside radius as I could put this as 2 and this is 3, right? This should work. Okay, there you go. That creates a sphere which goes outside the window, so I can just use this fit view command to bring it back to the window. So that creates just a sphere. And the next thing which I am going to do is create a cylinder, right? Here the cylinder is going to represent the rectum. Okay, so I'm going to make a hollow cylinder. This hollow cylinder will run like this. This has to have a certain x and y, right? So where do I want this to start from? So y can stay at maybe something from where it actually starts, right? So x wise I want to be at like a little bit above 3, so so that there is no overlap, because if there is an overlap between two systems or geometry, then you straight on go for the overlap option, right? You do not invoke the contact pair. But if there is a slight gap, changing gap, what we are trying to look at here, then you have to use contact pairing, right? Okay, so along the y direction, let me do this. What I'm going to do is I'm going to focus the cylinder here. So at a y of maybe 3, right, 3 units, this should be okay. And along the x, I would like it to be focused at 0 0. So 0 along the x should be okay. So the cylinder is somewhere here, and then it has a certain depth, right? So the radii 1 would be, so this would be the central line. So maybe I can put it to maybe 5-ish and make the outside radius as 2, right? That way 5 minus 2, it's going to interact, and the inside radius as 1, right? What should be the depth? It should be somewhere, starting from, so x is equal to 0 is point this. So I want a depth of, let's say, around 5 units. That should be okay, right? Okay. So there is my system which I have in place. So let's assume in a realistic condition, the sphere is a bladder, and this human urinary bladder, and we are looking at the hollow cylinder as the rectum from which you pass the stool. So you have the bladder and the stool, and this is a very common problem where you look at a lot of urinary incontinence and other issues, right? Like, so I'm just using some simplifications of some organs which are out there, right? So that's great. So I have two geometries here. Now the interesting part is, if I want these geometries to interact, which they are clearly not doing currently, I would like to initiate a contact pair between the two surfaces. So let's look at the two facing surfaces. One is a surface here, which is a curved surface on the sphere, and one is another curved surface on the cylinder, right? So how do you make them interact? Should it be a total surface to surface contact, like this entire surface is like interacting with that surface, or it should be like a partial surface to surface contact? How do we take these kind of decisions, right? So this is based on how we define the contact pair, right? We can have it wholly interact, or we can have partially some part of it interact, which is typically the case in majority of the soft tissues, where you have a fascia kind of material in between, and there is a certain interface for interaction, and that is where they're intersecting only, right? So let's take a look how we can achieve this. So before we can do anything with the contact pair, what we'll have to do first is assign the meshing, right? So let's conduct the meshing. The mesh tool, I'm going to set this to, by default it is material number 1, right? So let me assign the material number 1 to the sphere, hollow sphere. There is some warning, of course, but we could see very well that the meshing is not very nice. It's large elements, and you would see this not as an exact sphere. It has some edges, and there are some rectangular edges on the end, but it is okay. So I would like to re-emphasize our learnings on the mesh convergence study, where we want to make sure we select an optimal mesh in order to create a mesh which will not change the results. So if you change the mesh a little bit beyond this point in the number of elements, it's not going to change the results drastically, right? Not more than 5 or 10%. So that's what we did in the study of mesh convergence study, and that needs to be applied to all the models which you study, right? I'm just going to skip that because doing that every time is cumbersome. Okay, so here is the first mesh. Then I'm going to plot multi-plots that allows me to look at the all the volumes as well as the meshes, right? I could just very well write them as volumes. That way these vanish, right? Next is I want to mesh the cylinder with material number 2. Okay, done. Okay, so I have two meshes. What are the number of elements? It's probably not a lot. 820 elements. So it's a fairly coarse mesh, right? So the next thing is I want to go to plot controls, numbering, and just make sure that the element or the material numbers are actually different. So I'm going to set this to colors only, and that could be clearly seen that these are two different material meshes. Next is what I would like to do is create a contact pair now. Do I have to assign the loads and boundary conditions now? No, not necessarily. I could apply them at a later stage as well. That's fine, no issues, right? Okay, so when we go for a contact pair, we typically go under the modeling tab and we go for create contact pair. A contact wizard typically opens up, and you just have one option which is clickable here, and when you click on that, it lets you select a target surface. So we had been talking about which one is going to force onto which one, that defines the contact and the target, right? They can be used in a vice versa way, but the definition, if adhered to, would be really good for your simulation. So let us pick a target. Let's assume that there is a urinary incontinence, which is difficulty in urinating due to some prolapse or overlap or some level of like forcing of the rectum on the bladder. Let's say that's the clinical condition which we are trying to address, right, or simulate. So my target would be the bladder and the contact would be the surface on the rectum. So let's select these outer surface. I'm not able to do that here. I've selected an inner surface, so maybe I want to reevaluate. Yeah, this is better. Okay, so I've selected the outer surface which should be in contact, which should be the target. Then this is automatically selected. Next I pick the contact. This should be this outer surface, right, which is facing this one. Good. Okay, next is contact, target, both are selected. What I want to do next is go to optional settings and look at a few things. The first thing is I want to look at behavior of contact surfaces, which has to be set by default to bonded always, just to make sure there is no slippage or other kind of frictional conditions which are applicable during establishing the contact pair. It should be properly glued or properly bonded, as if they're welded or glued together. Okay, the next thing is these are bonded always. The next thing is we go for initial adjustment. Here I've told you we need to always exclude everything by default. There is a gap, it's a changing gap between a sphere and the surface of the cylinder. So what you could consider is this one, close gap reduce penetration. This is to be by default set. The next step is contact surface offset. We were talking about this contact surface offset the last time as well. Whenever there is a gap between two geometries, whether they are flat or whether they are curved. Let's say in a flat system you have a gap of 1, you would always select the contact surface offset to be a little bit greater than 1, maybe 1.52, 56, anything will suffice. Why not go very high? Because then it will try to consider the entire body. You just want to establish contact in the adjacent surfaces, right, not to all the surfaces.